our next keynote address. And I'm delighted to welcome back Adam Mullerweiss, the Chief Sustainability Officer at Clarios. He's talking the path to automotive circular economy. Hello again, Adam.
Hello, and thank you for having me.
You're very, very welcome indeed. And you have a whole keynote for us. So as they say, the virtual floor is yours.
Thank you very much. And I'm very happy to be joining you here from the home of Earth Day, Milwaukee, Wisconsin. It was actually founded by the U.S. Senator Gaylord Nelson from Wisconsin 1 year before I was born in 1970. So I can say every year of my life that we've celebrated Earth Day, but I would say for all of us, every day is Earth Day, and how do we live within the constraints and resources that we've been given. And one of those key opportunities is related to mobility, and particularly the automotive circular economy. And I'm happy to say it's a path that we're already on, and I will get into that. And then I will talk about the challenges, but also the opportunities for the circular economy for electric vehicles. So again, thank you for Sustainability Live for the chance to talk to you today, and really appreciate the opportunity. So let's first introduce you to my company. We are the world's largest producer of low voltage batteries that are essential for vehicles to operate, perform at peak efficiency, and to keep people safe. These may not be the high voltage batteries that are in the news that maybe come to mind with electric vehicles, but without the kind of batteries we make, the electric vehicle does not move. So we partner with the world's automakers and the world's automotive aftermarket to keep those vehicles in motion and, quite frankly, to keep the world moving. We're not only the largest producer of these batteries, we're the largest recycler, recoverer, and reuser of those materials to create new batteries. So in essence, we take old batteries and turn them into new batteries at an unprecedented scale. In fact, across our global network, we recycle 8,000 batteries every hour of every day to turn those into new batteries using raw materials that take 90% less energy and greenhouse gas emissions to create and to refine for our battery solutions. So before we get into the details of the automotive circular economy, let's talk about what is circularity. What is the circular economy? Well, let me start with a very simple, bold, and some might even consider a trite statement, but a circle is not a straight line. In fact, it's a very unique paradigm, and it's hard to even comprehend because we're accustomed to a world that is truly linear, that has more of a take, make, waste approach to it. So resources are taken out of the ground or taken out of planetary resources for some specific purpose. Someone else is using those resources to make those. The product is sold or used, it has end of life, it reaches a waste state, and we try to find some place to put that waste. So if I could simplify that even further, it's one and done. Now, most of us have grown up hearing about reduce, reuse, recycle, maybe even remake. That is part of the circular economy, but it's not truly the ultimate objective. So yes, we want to reduce the amount of resources that we use. We want to reuse them, but far too often they've been reusing them in other applications or downcycling, if you may. There may be opportunities to remake and remanufacture products, but that is too far and few between. And then ultimately, recycling is something that happens in certain sectors with certain materials, but doesn't necessarily happen at a massive scale for very specific products or solutions. So let me call this one and then some. So what is the circular economy then? Circularity is being able to make a product out of the product that you've originally used and made, to use that product and to maximize the value and durability of that product, and to recover it and cycle that product over and over and over again. And for us, it means our supply chain and our customer start at the exact same point when a car battery, a low voltage car battery, is taken out that had reached the end of its life. We recover that battery for the raw materials, and a new battery is placed in that vehicle. So it truly is a very different paradigm when you're starting with your consumer also being your supplier, but it's one that is really critical to unlocking the circular economy. So as I move forward with our discussion here today, I'm really going to be focusing on products that are made, used, and then ultimately cycled, and most notably talking about automotive vehicles and in particular cars. But before I do that, let's talk about the number of vehicles that are on the road, all different types, from motorcycles to heavy-duty trucks. In the world today, there's about 1.4 billion vehicles on the road. That's a significant and staggering number that is expected to grow to double that by 2050, even with ride sharing and different types of electromobility and those types of trends. There is a desire and a need for more vehicles. But even today, 78% of all transport emissions come from these vehicles. So this is a critical component of the greenhouse gas footprint of our society, and one that requires the utmost attention. But it also is something, as I mentioned, the number of vehicles are expected to double. That's because 82% of the world's population does not have personal mobility. They don't own a car. There are definitely opportunities for them to do so, but how do we maximize the value of that personal mobility so we can manage the greenhouse gas footprint and we can achieve the societal benefit of the mobility that it provides? So let's talk a little bit more specifically about cars. And I'm going to talk about some numbers here from a US perspective. So internal combustion engine vehicles have been with us now for over 100 years. We've been able to learn how to operate those. We've learned how to repair and maintain those, but we've also learned what to do with them at the end of life. So today, the average age of a vehicle on the road in the United States is over 12 years. And it's expected to go for over 200,000 miles. When I was born, the expected life of a vehicle, if you were lucky, was 100,000 miles. So just within 50 years, you've seen the doubling of the expected life. That means we're getting more and more out of the resources that are put into that vehicle. But every year, there are 14 million cars that are scrapped and reach the end of life in the United States alone. That is roughly the equivalent amount of cars that can be produced, new cars, with the steel that can be recycled and recovered from those vehicles. In fact, about 60% of the car's weight is from steel and iron that can be recovered and recycled. So let's talk about electric vehicles. They're relatively new. In fact, most of the electric vehicles on the road are less than 4 years old. They still have a considerable amount of life left within them. In fact, the projections are that they could go 250,000 miles or more. And I'm going to go into a little bit more detail on that here in a bit. But the number of vehicles that reach end of life are very few. In fact, they would only be accidents or major failures. We don't see large quantities and numbers of end of life EVs at this stage today in the United States. Now, certainly over time, that is going to progress. We're going to start to see longer life spans and more older electric vehicles on the roads as those continue to cycle. But it's an imperative that we look at what has worked on the internal combustion engine side in terms of managing the materials and the opportunities, and we translate that to the new electric vehicles that will be coming to the roads in increasing numbers in the coming years. So today, 80% or more of the materials that are used to create an internal combustion engine vehicle can be recovered, recycled, and reused. As I mentioned, 60% of the weight of a car is steel and iron, which can be collected, reused, and turned right back into auto bodies and auto components for new vehicles and electric vehicles. But electric vehicles have additional components because of their electric drivetrain and their battery, which are still being assessed and determine how best to recover those, recycle those, and to create the kind of closed loop system that we've established for conventional batteries for these new lithium ion and other advanced battery technologies. So this is a work in progress, but there's so much that we can learn from and build up upon from traditional vehicles and the recycling and recovery practices that are underway. That steel, that iron, the conventional batteries can be recovered and recycled, as I mentioned earlier. So there's also the utilization of these vehicles to make sure that we maximize the value out of them. Far too often you hear about the warranty period of an electric vehicle. In California, it's 80% of the capacity of the battery and 150,000 miles. This purple bar represents the capacity utilization that can vary from different vehicles, but it can go as far as 300,000 miles with still a very significant capacity of the vehicle. So we expect these vehicles to continue to be on the road well after the period of time that may be in the warranty, which is very similar and common to what we've seen in the internal combustion engine world. So this is something that we expect more electric vehicles to come on the roads, that they may move from long distance driving to shorter distance driving, to maybe occasional use as a second or third vehicle, and in fact will continue to be maintained in a similar fashion to what internal combustion engine vehicles are handled and maintained today. So there has been discussion of second life opportunities for those battery packs. There may be some opportunities, but we see the ideal opportunity is to maximize the value of the vehicle and the utility of that vehicle and maintain it as long as possible and throughout the battery lifespan that's available. But once it does reach the end of life, it's critical to be able to recover those materials, especially the essential and critical minerals that are involved in the manufacturing of the battery pack and the cell assemblies. So this includes significantly more of these types of materials than you would see in a conventional internal combustion engine vehicle. This is where the imperative is, and this is where a lot of resources and efforts from the national labs in the United States to startup companies to my company are focused on efforts to try to determine how we best recover and reuse these materials, ideally to turn them right back into batteries at the end of life. And the reason why this is so important is because the impact of creating, refining, and preparing those materials to be used for battery production can take a considerable amount of energy and a considerable amount of greenhouse gas emissions. So by using recycled raw materials for these batteries, for these battery packs, you achieve a 28% lower greenhouse gas emissions in their next use. But ideally, you continue to use these materials over and over and over again. We're not there yet, but there, as I mentioned, a lot of work, a lot of effort going in to really identify those opportunities and to be able to capture not only the greenhouse gas and energy value, but also the economic value of being able to create this circular economy. I started by talking about how my company has a network around the world to be able to recycle conventional automotive vehicle batteries like you've seen in my presentation, and we do that at a significant scale. Part of what we're focused on is figuring out how can we take that network which can collect batteries from the Arctic Circle to the Yucatan Peninsula here in North America and leverage it to be able to capture lithium ion and other advanced chemistries from electric vehicles and other applications moving forward. So we have a tremendous foundation to build on. We have the experience within the automotive sector of being able to develop, deliver, recover, recycle, and ultimately reuse these materials in very successful ways at scale. There's also a very consistent and constant source of remanufactured and reused parts from vehicles. Let's say you need a car door replaced, you need an engine in the conventional engine world, they have remanufactured those for continued maintenance and use of a vehicle. We believe that components of vehicles in the electric sphere will continue to be reused in a similar fashion to what they are in the conventional engine world. And we also see components of the drivetrain ultimately being reused and remanufactured as well. So what is exciting about this space is the number of parties and stakeholders that are coming together, as I mentioned, to work on this challenge. And we're proud to have been one of the founders of the Responsible Battery Coalition, a group of leading auto manufacturers, retailers, recyclers, logistics providers here in the United States that's focused on the responsible practices and recycling and recovery of the batteries of today and tomorrow, working with academia, working with other organizations like the Global Battery Alliance, which we're also proud to have been a founder of, which originated in the World Economic Forum and now is a standalone organization that is focused on a battery passport concept to be able to track the raw materials that are used in batteries and cell and pack assemblies from their source, to be able to have transparency throughout the supply chain and the value chain through manufacture, through the use in a vehicle, being able to manage the chain of custody at the end of life of that vehicle, and that battery pack and that cell assembly, being able to help remanufacture or reuse or extend the life of that vehicle and that vehicle pack. If there is an opportunity for second life, to be able to manage the chain of custody for that. But ultimately, at the end of life, to be able to have the accountability and transparency and data to show that that battery, that cell assembly, those packs have been responsibly recovered, recycled, and ultimately reused. So as I mentioned, there's a lot of work and effort. The Global Battery Alliance consists of automakers, governments, academics, companies like mine that are really focused on this common aim about establishing and accelerating a transparent and circular economy for, in particular, automotive and vehicle batteries, where we can build on that experience of automotive recycling to take it to the next level and be prepared for the next generation of vehicles. We're also incredibly proud of our role to be able to work with the world's automakers as they seek to create a more circular vehicle. There are several automakers that have introduced concepts and really have goals and targets to use more recycled material in their vehicle, and ultimately to be able to design the vehicles to be completely circular so they can be disassembled, reused in certain components, recycled, recovered, and remade into new components so you can create a truly circular vehicle. So this is something that is a path that has started in fact, generations ago with some of the very early recycling, recovery, reuse of automotive components to a very well-organized, comprehensive network of recycling automobiles today with leading products and solutions like batteries that we make are recovered and recycled at a rate near 99%. To be able to turn those components and those batteries back into new ones. That opportunity, that precedent is there, that experience within the automotive sector is there, but the opportunity is clearly ahead of us to be able to design and deliver solutions for those 82% of the world's population that doesn't have access to personal mobility, and to do it in a way that can extend the life of that vehicle and maximize the use of those resources. And when those resources are ultimately done, we will be able to recover, recycle, reuse, and ultimately return them right back into an automotive application over and over and over again. So I wanted to thank you all for the time to talk to you a little bit about the automotive landscape, the circular economy of the automobile, and where this is headed. It's certainly an exciting time. I was only able to scratch the surface here in the limited time that we had available to us, but I wanted to leave some time in case there were questions or comments, but do really appreciate the time here today and wish you a great rest of the conference.
Adam, thank you very much indeed. I've got a couple of quick questions, if I can, just to start off. It's a two-part question, really. For you, what can the automotive industry learn from other industries in terms of trying to make the product more circular? And what can, the other way around, other industries learn from automotive, in your opinion?
Sure. So I think the automotive sector is one that it isn't a monolithic sector in itself. It leads into the electronic space. It leads into other manufacturing areas. It leads into consumer products. So there's definitely learning and cross-pollination that's happening already. I think there's, as you mentioned, a two-way street. The design for circularity, the design for sustainability, design for remanufacturing, reuse, recovery, those are all things that have been part and parcel of the automotive sector for generations. And those are things that we are bringing to the world and to other sectors. And we look to learn from those sectors as well.
We were talking earlier, as you were, about the electric vehicles more and more entering the marketplace. As you say, most are under 4 years old. When we're getting to 10, 15, 20 years, when they're starting to reach the end of their life, where do you see the challenges there emerging about making sure that they act in a circular way?
Sure. So first and foremost, it's getting the absolute most out of that life of that vehicle, as I mentioned earlier. And then it's making sure you have the systems in place, like I talked about the battery passport, to make sure you know what is in what vehicle where in terms of a battery, the type of chemistry and technology. So there is an opportunity to potentially reuse that in other applications if there's still remaining capacity in that battery that may no longer be used in the vehicle. But if there is no future life left in that pack, to be able to direct it and to work with recycling and recovery companies around the world to be able to disassemble, to be able to take those components, those critical minerals that I mentioned earlier, to be able to start to resupply that circular economy that's creating the next generation of electric vehicles, the next generation of vehicle battery packs for tomorrow.
Getting on to some questions from our virtual audience. Thank you very much. You never let me down. First one, this will put you on the spot slightly, for which I apologise for. This is from Tim and is for you. Which manufacturers are leading the way?
So I would say it's fair to say that there is different pressures in different geographies that are forcing automakers to look at this space a little bit differently. So an automaker, a global automaker that may be based in Europe, has to sell vehicles in California. So there may be different rules and regulations and incentives in different countries that are pushing automakers in different directions. But we are seeing, quite frankly, a lot of innovation coming out of the European automakers, but there are pockets of innovation and really creative thinking about how to put these resources to work more efficiently from all the automakers around the world.
So it's almost a case of pooling the best practice. Everyone is still operating in an industry which, well, when it comes to the circular economy, is relatively in its infancy. And that's something I wanted to move on to when it comes to the lifespan of batteries. Again, this is a question from the audience. Do you think there's going to be an opportunity to really extend the lifespans of battery elements to reduce any potential waste?
So I'm not a scientist or an engineer, but I'm one that looks at history. And the fact that we have been able to extend the life of an internal combustion engine vehicle and the vehicles from 100,000 miles to 200,000 miles in my lifetime tells me that there's innovative people, creative people, there's solutions, there's technologies out there that we may not have fully grasped yet that can be applied to these types of vehicles. So I'm an optimist. I think we have a track record of being able to innovate and find new solutions. So I think it's only a bright future for longer lasting, more durable batteries and extended life for electric vehicles in the future.
Okay, Adam, thank you so much for joining us at Sustainability Live New York. It's always nice to finish a keynote on a positive note, which seems to do a lot here because we're talking about so many good positive stories. Adam, thank you so much.